This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on parametric equations. We're going to take a look at the following example. We're going to say that x of t is t minus 1 and y of t is 2t squared. We're going to think of t as a time parameter. As t changes, x and y will change. So I'm making a table of values here. So you'll see I'm going to have values for t, I'm going to have values of x, and I'm going to have values of y. If t is negative 2, negative 2 minus 1 is negative 3. Negative 2 squared is 4 times 2 is 8. If t is negative 1, negative 1 minus 1 is negative 2. Negative 1 squared is 1 times 2 is 2. 0 minus 1 is 0. 2 times 0 squared is 0. 1 minus 1 is 0. 2 times 1 squared is 2. 2 minus 1 is 1. 2 squared is 4. 4 times 2 is 8. So we get this table of values for our parametric equation for various values of t. Now I'm going to plot the points x and y. So we don't plot the values for t, but we do plot the values for x and y. So I'm going to plot negative 3, 8, negative 2, 2, negative 1, 0, 0, 2, and 1, 8. So you'll notice there's 0, 2. Here's negative 1, 0. Here is negative 2, 2. Here is negative 3, 8. And you'll notice the graph looks like this. As t increases, the graph goes from left to right. So I put little arrows on there to represent the orientation. For any parametric curve, it's going to have an orientation. So as t increases, which way is the graph growing? Here is negative 3, 8 when t is negative 2. Here is negative 2, 2. Here is negative 1, 0. Here is 0, 2, etc. So as I'm writing on my sheet here, the arrows represent the orientation. So as t is increasing, the graph is moving along this direction. So that's the orientation of our graph. Now our next goal is going to be to eliminate the parameters. So we're going to be giving an equation that is in parametric form. We want to eliminate the parameter t and rewrite it, express that as an equation in x and y. So we'll see how this works. So can we express that parametric equation as an equation in x and y? So what will our process be? Take a look. So I'm going to have x and y. So x is going to be t minus 1, and y is going to be 2t. The strategy is going to be to solve for t in the first equation. So I get x plus 1 is t, and then replace that t up here with the x plus 1. So we get y is 2 times quantity x plus 1 squared. And then I have successfully rewritten that as a function in x and y, eliminated the parameters. So the thing I am circling here is the solution after the parameter is eliminated. Now what's the next thing we're going to look for? We're looking for a slope, the slope of the tangent. So you recall from earlier that the slope of the tangent line can be considered dy dx. But how do we find dy dx if we're given a parametric equation? So what I'm asking for here is to find the slope of the tangent at the point when t equals 1. So indeed, remember that slope is dy dx. How are we going to use that here? We're going to say slope is dy dt over dx dt. That'll be our slope of a tangent for a parametric curve. Now we saw up here that y was 2t squared. So the derivative of y with respect to t is just going to be 4t. X, of course, was t minus 1. So the derivative of x with respect to t is just equal to 1. Now putting these together, again, dy dx is dy dt divided by dx dt. We're going to get that the slope is just going to be 4t over 1. which is of course just 4t. But I wanted the slope of the tangent when t equals 1. So what is dy dx at the value where t equals 1? That's going to require me to plug 1 into 4t. So it'll just be 4t when t equals 1, or 4 times 1, which will be 4. So the slope of the tangent there indeed will be 4. So let's see, what is our next concept? We're going to start with the circle. The circle is x minus 2 squared plus y plus 3 squared equals 16. Can we express that thing in parametric form? What sort of a strategy will we use here? Well, you'll see that the first move is going to be to divide everything by 16. So we'll have x minus 2 squared over 16 plus y plus 3 squared over 16 is 1. And then how can we rewrite that? Well, that x minus 2 over 4 quantity squared, because 4 squared is 16, plus y plus 3 over 4 quantity squared, again 4 squared is 16, will equal 1. What do we need to remember? Our basic identity from trigonometry, cos squared theta plus sine squared theta equals 1, which will recognize this form sort of looks like that. Using our other notation, I'm going to say cos t quantity squared plus sine t quantity squared equals 1. So x minus t over 4 will be cos t, y plus 3 over 4 will be sine t to get those to match, as we see here. And then we're going to be able to solve for x and y. So we'll say 4 cos t is x minus 2. And then adding 2 to both sides, 2 plus 4 cos t is x. So that's one of our parametric forms. And then on the other side, multiplying by 4, 4 sine t is y plus 3. Adding negative 3 to both sides, negative 3 plus 4 sine t is y. So I've written this thing now as a parametric equation. So sometimes we say x, sometimes we say x of t. But just rewriting it one more time, the x is 2 plus 4 cos t, and the y is negative 3 plus 4 sine t. That's going to be our circle centered at 2, negative 3, with a radius of 4. But using our fundamental identity, cos squared theta plus sine squared theta equals 1. Worked out fairly well there. So what's our next concept going to be? Again, we're going to look at the slope of the tangent line. Remembering dy dx is dy dt over dx dt. This time we want the slope of the tangent at t equals pi over 6. So recall, again, our basic idea. Dy dx is dy dt over dx dt. What were we given? Starting with the y part, y was negative 3 plus 4 sine t. So what is dy dt? That would just be 4 cosine t. The x portion of that parametric pair was x equals 2 plus 4 cosine t. So what is the dx dt part going to be? Dx dt will be negative 4 sine t. And again, our basic rule that we have up here, dy dx is dy dt over dx dt. Making the substitution, we'll say dy dx is 4 cos t, the dy dt part, divided by negative 4 sine t, the dx dt part. Or if you like, just negative cos t over sine t. And we want the slope of the tangent at t equals pi over 6. So writing it that way, dy dx at t equals pi over 6 will simply be negative cosine of pi over 6 divided by the sine of pi over 6, which is what? Negative root 3 over 2 divided by a half, which gives me negative root 3. That'll be the slope of the tangent at t equals pi over 6 for this problem. The next thing I'm going to ask is to eliminate the parameter of a different kind of equation. What are we going to have here? Eliminate the parameter of x of t, which is e to the t minus 1, and y of t is 5e to the 2t. Now, you might be tempted to solve for t, but that's not the simplest strategy here. I'm going to instead solve for e to the t. So x plus 1 is e to the t. So x plus 1 squared is e to the 2t. And that's what gets replaced. So that simply becomes 5 times x plus 1 squared. Our next situation then is to eliminate another parameter. What are we going to have here? X of t is 2 plus 5 cos t, and y of t is negative 3 plus 4 sine t. So we're going to solve for cosine and sine here. So x minus 2 is 5 cos t. So x minus 2 over 5 is the cosine of t. Y plus 3 would be 4 sine t. Y plus 3 over 4 would be sine t. Remember, we have our fundamental identity that we use, cos squared theta plus sine squared theta is 1. And that's going to go ahead and give us the version of this that we want to use. So thinking of it as cos t squared plus sine t squared equals 1. Replacing cos t with x minus 2 over 5 and sine t with y plus 3 over 4. We're in pretty good shape, and we have successfully eliminated the parameter there. Just a quick reminder, this is an ellipse centered at 2, negative 3. So if you want to draw this, what will that look like? So we go to the center, x is 2, y is negative 3. And then our radius, as far as x is concerned, is 5, so that's to the right 5, to the left 5. Our radius, as far as y is concerned, is up 2, down 2. So if I put all that together, I can get my graph of that ellipse. And we'll think a little bit about the orientation here as well. So let's see. There is my 2 over 3 down. There's the center of this ellipse. And I've got to go 5 to the left, and I've got to go 5 to the right to correspond to the 5 in the denominator. And then to correspond to that 4, I've got to go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. That gives me the ellipse. And the orientation of this ellipse is going to be a counterclockwise orientation. If we would have started this way, what will you notice? If t is 0, cosine of 0 is 1. So that'll give me 2 plus 5. I'm at 7 on x. If t is 0, sine of 0 is 0. Negative 3 plus 0 is negative 3. So you can see all the way over at 7, negative 3. This is my starting point when t is 0. Then when I go to t is pi over 2, cosine of pi over 2 is 0, so my x value is just 2. Sine of pi over 2 is 1. Negative 3 plus 4 is going to give me 1. And you can see there's my 2, 1 value. So the function starts here in my initial point and then comes here. So you can see what our orientation is. Our orientation is going this way. It's going to have a counterclockwise orientation for us. And that will complete this lesson.